the definite integral from 0 to 4 of x divided by 2 dx. Okay, so the first part, just sketch a region. And then it says use a geometric formula to evaluate that region. I'm going to pause our recording right now. The problem with you guys, you know what the problem is?
You don't try.
Well, I wasn't going to go quite that harsh. I was going to say, you really try to make it too difficult, okay? You try to make it too difficult. But maybe you don't try. Okay, I'll take that. But you try to make it too difficult. This is the function that you need to graph. Who doesn't know what that looks like, okay? But if you think about it that way, that's a pretty simple function. Okay, so let's just sketch it out. I won't even have us put it on the Inspire, Nash, because I don't think we need to. Okay. So let's see. What is my interval? 0 to 4, okay, 1, 2, 3, 4. If I'm going to graph x divided by 2, that means that when the input is 4, the output is 2, okay? I mean, this is just a simple line that looks like that, okay? So this is the region that we're going to determine the area of. This is part A. Part B says use a geometric formula to evaluate this. Now you see that, you got it, right? Area equals. See, I told you, you're thinking too hard. You're making it much more difficult than it has to be. It's just a triangle. In fact, it's about the easiest triangle you can do. It's a right triangle. Okay, so 1/2, what's your base? What's your height? You're using, the left endpoint. If you look at one rectangle here, the left endpoint, but our area is 4 square units. Now, when we take the integration of this, we should get the same answer. Agreed? We should. Okay, here we go. This is not called for. This is not what we need to do, but we're going to go through it anyway. By the way, we're looking at this, and without showing you how we're actually integrating and getting that, we know that our answer must be 4 square units. So there's a shortcut. There's always shortcuts, but we're not going to do that right now. Right now, we're going to do extra. And this is now going to be back to section 5.2. So if you have looked at that section and you have a general idea what's going on, you'll know what I'm doing here. Okay, so if I want to find the area under this curve, this line, and down, we know the answer is 4. But how would we go back to section 5.2 and set it up that way so we get an answer of 4? Well, first thing we have to do is take the limit as n. We're going to take n going to infinity. We're not going to do that delta x going to 0. We'll do n going to infinity. The limit of what? Well, of the summation as I goes from 1 to n. Remember, we're letting, over here in the limit, we're letting n go to infinity, but right now we're just going to sum up a bunch of rectangles. So we've got I going from 1 to n. I need to know what is the width. Let's do that first. What's the width of each of my rectangles? Remember we talked about, delta x is b minus a divided by n, and delta x is our width. So what would be our width? B is 4, a is 0. How many do you want? N of them. We're not saying we want just 2 or 3 or 4. We want n of them, because we're going to let n go to infinity. Okay, so the width is 4 divided by n. What's our height of each of these rectangles? Okay, in order to do that, remember back in section 5.2, we had to determine, are we going to use the left endpoint or the right endpoint? Now, I don't know how you feel about determining those, but I think it's easier to always go with the right endpoint because you don't have the I minus 1 to deal with. And so if we go with the right endpoint, now when we're talking about that, remember, for each of the intervals, we're going to use then the right endpoint to determine the height. Now in this one, if I use the right endpoint, that's going to be f of whatever I determine that right endpoint to be. That's the height of each of these. And by the way, I'm going to overestimate my area by doing that. Okay, so if I use the right endpoint, I'm going to have to do that by 0 plus, and it's going to be 4i divided by n. Okay, because I've got these intervals going on, and for the first rectangle, I would have I to be 1, and so it would be 4 divided by n. For the second rectangle, it would be 8 divided by n. For the third one, it would be 12 divided by n, and so forth. Okay, if it's the fourth one, I'd have 16 divided by n. And so I'm going to use then just 4i. But how do I use the fact that this is the right endpoint? How do I determine the height? Caleb? Yes, because it's the function's value that is determining the height of that. So this is going to be f of 4i divided by n. Okay, so I've got my width and I have my height. I'll put that in brackets so we make sure that we understand. That's f of 4i divided by n. Now, if I've got it set up now. The hardest part is determining that endpoint. If I understand width and height of a rectangle, I've got it. So now I just have to go through and look at the limit as n goes to infinity. I've got to find the summation of this. I've got a couple of things I can do. First of all, I've got to put 4i divided by n back into my function. What's my function? X divided by 2. So we need to identify that f of x is x divided by 2. Okay. So I need to understand that 4i divided by n now is going to go into my function. Second thing I can think about is I'm letting I range from 1 to n. What's the role of 4 divided by n? Is it changing? Does it have an I in it? Called a scalar. What do you do with scalars? Pull them out in front. Okay, if you go back to section 5.2, you'll see that if we have a scalar multiplied to a function, that we can pull it out in front. It's one of those properties. So now I have the summation as I goes from 1 to n of f of 4i divided by n, which means I have 4i divided by n divided by 2. Well, that's the limit. I have to admit my limits get a little scratchy there. I think you can read them. If you have the same problem with writing that out, I accept it, okay? 4 divided by n, summation as I goes from 1 to n. How are you going to resolve the fraction divided by 2? Well, I'm dividing by a fraction, so yeah, multiply by the reciprocal. So if I multiply by the reciprocal, I'm going to multiply by 1/2. Because this is the first time I've done it with you in class, I'm going to write that step out. Some of you already know what that is, but others of you might need. Okay, so I have the summation as I goes from 1 to n. And this now, let's see, the 2's cancel. Our 2 goes into 4, so I have 2i divided by n. I'm getting tired of rewriting this whole thing. I'm going to do an erasing here. But do you see how I got the 2? Okay. I also see, if I rewrite this properly, that I could write this as 2 divided by ni times I. Same thing. Remember, this was 2i divided by n, so 2 divided by n times I. What's that make 2n? Another scalar. So I have the limit, n goes to infinity. I've got the scalar 4 divided by n. I now have the other scalar 2 divided by n, and now comes in Carl Friedrich Gauss. I'm summing up numbers from 1 to n. Okay? So this goes back to that second page, I believe, of section 5.2 notes. What is the way that what's the other way of writing the summation of numbers from one to another? So I have the limit, n goes to infinity. Please allow me to write this as 8n squared. And how do we have this? Brendan, do you have that memorized? That's one of the easier ones. Think of Carl. How did he add up 1 to 100? Anyone have this? Yeah, Emma? It won't be I, because we're letting, yeah. Yep. Yeah. Okay. Remember, he took the numbers from 1 to 100, then he reversed them 100 down to 1, and he had 100 combinations of 101. Okay. So 100 times 101, but he did that twice, so he needed to divide by 2, and his chance was 50-50 of getting the right answer. I always like that joke. But anyway, you don't get it, do you? 1 to 100, the sum of all those is 5,050. Okay. Anyway, when you have to explain a joke, it kind of loses it in translation. Okay. Anyway, here we go. Now I'm down to just a limit problem here that we had back in chapter 2. So all I have to do, go through and do as much as you can to simplify this. I'm going to subtract a power of 2 or n in the denominator, and I get the limit. N goes to infinity, and I end up with n plus 1 divided by n. I'll give you a moment to look at that, verify that I didn't subtract or do something wrong. This n came down, and I subtracted a power down here. 2 divides into 8, 4. Whoops, where'd the 4 go? That's a good one. We'll just squeeze it in there. Okay. Actually, let me go back and write it a little differently so that we do have it. So we can use it. 4 n plus 1 divided by n. Now, as n goes to infinity, what happens to the fraction? That's the question, isn't it? Okay, so now we're in section, what is that section? Chapter 4, section something or other, 5, I believe it is. So now I need to find ways of taking n to infinity, and I see that I would have 4 plus 4 divided by n. Now do you see the answer? N goes to infinity, 4 divided by n goes to 0. The answer is 4. What did we hope to get? Answer 4. Okay, now I'm going to show you one more thing on here. Let's go to our inspires. And next we are going to graph this. Okay? And let's do x divided by 2. And we'll change the window here. Let's see. Well, let's let it go from negative 0.5, negative half, to we're going to 4. So we'll just go to 5. We don't need a lot of space there. We'll scale by 1. We don't need much here, so we'll go negative 0.5 again, 5/10. And let's see, we know that when we put 4 into the function, it only comes out to be 2. I'm going to use a 3 here. and a 1. So we'll just make it a win.